Good day everyone. Today let us see one sum in definite integral using properties in which we are going to use three properties. Okay. So I is equal to integral minus pi to pi 2x into 1 plus sin x by 1 plus cos squared x dx. When you see the limits as minus pi to pi, immediately you should remember the property integral minus a to a f of x dx is equal to, there will be two options there, that is two parts. One is 0 if f is odd, and the second one is twice integral 0 to a f of x dx if f is even. This is the property. So when you see both the upper and lower limits are same and the lower limit has a negation and the upper limit is positive, you should remember this property. You are having two parts. Okay, so you should know what is an odd function, what is an even function. So when your f of minus x is equal to minus of f of x, you say f is odd. When f of minus x is equal to f of x, f is even. Okay, so you should be familiar with these things now. Here you have the limits minus pi to pi, but if you straight away use this property here, we will not get either this or this. That is, we won't be able to get whether the given integrand is an odd function or even function. That's not possible. So what we are going to do is, we are first going to split it into two integrals and then let us apply this property to each part. Okay. So now first I am going to write it as minus pi to pi 2x into 1. So 2x by 1 plus cos squared x dx. And the second part is integral minus pi to pi 2x sin x by 1 plus cos squared x dx. So this is what I have done first. I am just expanding the numerator and I am writing this as two integrals. Now the 2 can be taken out. So I will write 2 into integral minus pi to pi x by 1 plus cos squared x dx. Here also I will take a 2 out, minus pi to pi x sin x by 1 plus cos squared x dx. So now my I can be written as 2i1 plus 2i2. So this is the first step 1, which is my final step. So I have represented as 2i1 plus 2i2. Okay. So let me write the 1 here for me to remember to have the final step, plus 2i2. So this is my 1 and I have marked it here. Now what is my I1? Let me write my I1. I1 is integral minus pi to pi x by 1 plus cos squared x dx. Now let me try this property. So now I will write my f of x is equal to, this is the integrand, that is the f of x, x by 1 plus cos squared x. F of minus x will be, I have to substitute minus x in the place of x. So I will be getting minus x by 1 plus cos squared of minus x. Okay. You know cos of minus x, that is equal to cos x. So cos squared is also, so you will be getting the same thing in the denominator. You will be getting 1 plus cos squared x. So now you see f of minus x is nothing but minus of f of x. So you know f is odd. So since f is an odd function, you can say I1 is equal to 0. You got this result. Call this as 2. So now our I1 is 0. So this is my 2. Let me keep this also separate. So now I1 is over. There is no need for me to integrate it because I got the answer as 0. Now let me go to I2. Okay. The I2 is x sin x by 1 plus cos squared x dx and the limits are minus pi to pi. So let me go to I2 now. Okay. So I2 will be equal to let me write that I2 is equal to integral minus pi to pi x sin x by 1 plus cos squared x dx. Let me apply the same property now also. Let me see whether this function is odd or even. So now here my f of x is equal to x sin x by 1 plus cos squared x. Okay, in the previous I1 you had only x by 1 plus cos squared x. Now you have x sin x by 1 plus cos squared x. Now what is f of minus x? This x is going to become minus x. Okay, here this is sin of minus x by 1 plus cos squared. This is going to be minus x. Now you know sin of minus theta is minus sin theta. Here is 1 minus, there will be 1 minus. So the numerator will become x sin x. This you already know, cos of minus x is cos x. So the denominator is 1 plus cos squared x. So now you get f of minus x is equal to f of x here. So f is even. When you consider your I2, the f is even. So now I will go to this part, that is the second part of that. So now I can write my I2 is equal to, by that property I can write now twice integral, okay, 0 to a, that is 0 to pi. Then I will write x sin x by 1 plus cos squared x dx. Okay, so this is the I2. So now we have used the two parts of this property, and I1 we have equated to 0 and I2 we got it as twice integral 0 to pi x sin x by 1 plus cos squared x dx. Right. Now you look at the numerator. You have an x here. This is a trigonometric part and this is a trigonometric part. Here it is like the 0 to a. Immediately you should remember that whenever we have an additional x in the numerator other than the trigonometric part, and if the limits are 0 to a, we can make use of the property integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. If you use that, we will be able to eliminate that x, then the integration will become easier. You should remember this. So now I am going to make use of that property. Now let me call this 3, because already I have 1 and 2. I will call this as 3. Now I am going to apply that property. So I will be getting now I2 is twice integral 0 to pi. Okay. So a is pi. So the x will become pi minus x. Then sin pi minus x by 1 plus cos squared pi minus x dx. Now, sin 180 minus theta is sin theta, you know. So, you will be getting here sin x. Here, cos 180 minus theta is minus cos theta, but you have a square. So, you will be getting cos squared x. So, now what will I get? Twice integral 0 to pi. The pi minus x you have to write as it is. Here you will get sin x and here you will get 1 plus cos squared x dx. Let me call this as 4. Now you have to add 3 and 4. You are going to add 3 and 4. So now here I2 you are adding. You will be getting 2I2, that is equal to. Here 1 2 is common. Then you write within integral 0 to pi. The denominator is same, so let me write it 1 plus cos squared x, right? Coming to the numerator, here I have got x sin x. Here I have got pi minus x sin x dx. Okay. Now, if you expand it, what will happen? The x sin x and minus x sin x will get cut, and you will be just getting 1 pi sin x by 1 plus cos squared x dx. Okay. So, now what will you get is, you are having here 2I2, remember that. So, now I will be getting here 2I2 is equal to twice integral 0 to pi. The x sin x will get cancelled. The pi I will take here. So I will be getting now sin x by 1 plus cos squared x dx, right? This 2 and this 2 you can cut. So now your I2 is pi outside integral 0 to pi sin x by 1 plus cos squared x dx. So because you use this property, you have eliminated the x and now the sum has become a bit simple for you. So now we have to integrate this I2 by substitution, because you have a sin x, you have a cos squared x here. So you can now put cos x is equal to t. When you differentiate it, you will be getting minus sin x dx will become dt, or sin x dx will be minus dt. Then remember, you have to change the limits. In definite integral, whenever you use substitution, substitute, differentiate, change the limits. Remember these 3 steps. So now when your x is 0, t will be cos 0, which is 1. When x is pi, t will be cos pi, which is equal to minus 1. So now the lower limit is 1 and the upper limit is minus 1. So I2 will be equal to, pi is outside, the lower limit is 1, the upper limit is minus 1. Sin x dx is nothing but minus dt. Here you will be getting 1 plus t squared. You know, generally the lower limit should be a lower number, okay, smaller number, and the upper limit should be a bigger number, greater number. But here it is other way. Here we are going to use another property, which is integral a to b f of x dx is equal to minus integral b to a f of x dx. That is, when the upper limit is a smaller one and the lower limit is a bigger one, you can either introduce a negation or you can remove a negation so that you can interchange the limits. This is one property which we are going to use here. So now I have a negation here, I will remove it. So now I will be getting pi integral minus 1 to 1. Okay, I have interchanged. Then I will be getting here dt by 1 plus t square. Okay, so now it is a straight formula. So you will be getting tan inverse t minus 1 to 1. So you will get pi into tan inverse 1 minus tan inverse minus 1. Pi is outside, tan inverse 1 is pi by 4 minus pi by 4. So you will be getting pi by 2 here. So pi into pi by 2, which is pi squared by 2. So this is your I2. You can mark this as your phi. So now already you know I1 is 0, that is your 2. Now you know your I2 is pi squared by 2. Now substitute these things in 1. So I will now become 2 into I1, that is 2 into 0. So that part is going to be 0 for you. Then 2 into pi squared by 2. This 2 and that 2 will go. So the answer is pi squared. So this sum, actually first what did you do? You split it into 2 parts. Then you have applied that minus a to a property. In one part it became an odd function, so you got it as 0. In the other part, in I2 it was even, so you use this. Okay, then after that you split it, you eliminated the x using this property, and then you use substitution, then you have arrived at the result. Do you understand this sum? You can subscribe to the channel and you can click the bell icon if you want to get notification of the further videos. Thanks for watching the video.